This is part of our video series on human-centered evaluations for NLP explanations. Check out the link for more resources. You're currently here.
I'll spend the rest of my section of the tutorial talking about this question. Should model explanations be similar to human explanations? Or is that a fundamentally flawed objective, making the whole idea of proxy evaluations kind of useless in this context? And as you might expect, the answer is a little bit complicated. We can think about what human annotated explanations don't do when we try to use them as a gold standard for model explanations. They don't tell us whether the explanation is really faithfully explaining the model behavior in an actionable way. This is more what so-called fully automated explanations tend to do. And they don't tell us whether the explanation is likely to be useful in some downstream task involving a human agent. This is really more what application-grounded explanations do. What they do is tell us whether the model explanation adheres to our expectations for the task. They tell us, did the model attend to constructions that we recognize as personal attacks? Did the model attend to the information that we thought was necessary and sufficient for answering the query in some kind of question answering task like multi-RC? Did the model attend to the content that we judged as discussing the one particular aspect of the beer within the beer review? But of course, this begs the question of how valid are these expectations? One exercise that helps think about this stuff is to visualize the pieces of an explained model prediction and the elements by which we can evaluate it. We have the model prediction, which I group with the true label because they are often considered relative to each other. We have the model explanation. We have optionally a human annotated explanation and, again, optionally a human agent trying to engage with the model output for some purpose. Conventional machine learning evaluation tends to think about the relationship between the true and the predicted label. How accurate was it? Fully automated evaluation of model explanations tends to look at the relationship between the model's explanation and its prediction. An example is the idea of sufficiency, which asks whether the tokens in a model rationale are sufficient to let the model make the prediction that it would have made with the full information. Application-grounded evaluations tend to look at how an actual human agent interacts with the model explanation in trying to make sense of the model's prediction. A very common control condition for this type of evaluation is looking at how the human agent interacts with the model prediction alone. And then finally, we have the conventional proxy evaluation with human explanations, where we're generally looking at the similarity between the human annotated explanation and the model-generated explanation. And the question remains, what can we do beyond this? One thing that we can do is look at the relationship between the human annotated explanations and the model predictions, as several recent papers have done. I'm going to mention two in particular. In evaluating and characterizing human rationales, we took a number of human rationale datasets, such as multi-RC and ESNLI, and we looked at whether the tokens included in the human annotated rationales were both sufficient and necessary for trained models to make predictions similar to what they would have made with the full data. By doing this, we can get a sense of how good a target the human annotated rationales are for model rationales. If the human rationales in a dataset never consist of enough information for a model to make a good prediction, then they probably shouldn't be used as a target for a proxy evaluation like the type that we've been talking about. In their recent paper about leakage-adjusted simulatability, Peter Haase and his co-authors do something very similar for free text explanations. They look at how accurate models become when the free text explanation is appended onto the end of the input, and they use these values to make inferences about the informational content of these explanations. To clarify what I mean, here is one result from evaluating and characterizing human rationales. This is a plot of how accurate a Roberta model is on 6 data sets. The gray bar is the standard accuracy of the model, trained and tested on the full input. The light blue bar is the accuracy of that standard model on just the tokens in the human annotated rationale. And the dark blue bar is the accuracy of a model both trained and tested on just the human annotated rationales. What's interesting about this result is that for most of these datasets, the accuracy of the model improves when it's applied to just the human rationale tokens, especially when it has a chance to adapt to that format during training. So what does that mean? Well, it means that human rationales for these datasets carry with them predictive signal. By designating certain tokens as relevant and certain tokens as irrelevant, they actually provide clues about the label that the model can pick up on if it has Oracle access to these designations. However, they don't convey full information about the label, and in some cases they can actually reduce the model's performance by occluding important information. This is the kind of informational property that fully automated evaluations of model explanations have tended to focus on, but there hasn't yet been that much work on evaluating human explanations in these terms. I like this kind of work because it begins to give us a sense of how valuable human explanations are in terms of what relationship they have with the model. Or to put it slightly differently, instead of worrying about form, as we do with a direct comparison between human and model explanations, we instead worry about the function that human explanations hold in terms of what informational properties they hold relative to the model. Moving forward, I think there's a lot of potential in evaluating model explanations relative to these informational properties, instead of, or perhaps in addition to, similarity. An example would be, does the model contain explanations that have predictive sufficiency relative to the predicted label that are at least as good as what the human explanation has to the true label? In my opinion, this idea of thinking about both form and function is a wide open area of the literature right now with a lot of low-hanging fruit. That concludes my discussion of human annotated explanations, how to collect them, how to use them as a proxy for evaluating model explanations, and the validity of similarity as a metric for success in doing this. I think moving forward, the community should focus more on the informational properties of human explanations and evaluating model explanations relative to these properties instead of or in addition to the content of these human explanations. Thank you very much.
This video isn't the end. You're currently here. If you're lost, click on the link below for source code, slides, and other resources.